Welcome in Cairo. Today we are going to revise and solve important problems on chapter 1. Also to study the graphs and what's meant by. Pay attention. Here in this example, if you have 6 waves passes by a certain point, these 6 waves that passes by a certain point in a time of interval of 60 seconds. 6 waves passes through a time interval which is 60 seconds. If the distance between the beginning of the first wave and the beginning of the 6th wave is 75 meters, find period or periodic time, find wavelength, find frequency, find wave velocity. Find wave velocity. So let's start. We have 6 waves. These 6 waves propagate through an interval of time which is 60 seconds. So easily we can calculate the frequency. So let's start by calculating the frequency. Frequency here equals number of waves divided time in seconds. Frequency equals number of waves divided time in seconds. We have only here 6 waves, and the time in seconds is 60 seconds. So 6 divided 60 equals 0.1 hertz. That's for the frequency. Okay, but to calculate the periodic time or the period is very easy. Periodic time is the reciprocal of the periodic time, the reciprocal of the frequency. So periodic time T capital equals 1 divided nu. 1 divided nu. So here 1 divided nu, 1 divided 0.1 equals 10 seconds. That's for the periodic time. But to calculate the wavelength, you have to concentrate well. I told you in this example, the distance between the first wave and the 6th wave, this distance is 75 meters. Between the first and the 6th, so 75 meters covers how many number of waves? From the first to 6th, so 6 minus 1 equals, yes, 5. So the number of waves for this distance for 75 meters is, yes, 5 waves. So lambda wavelength equals distance divided number of waves. Distance is 75 meters. Number of waves from the first to the 6th, so the number of waves is 5. So 75 divided 5 equals 15 meters. So to calculate the velocity, velocity equals lambda nu. This is a general relation for all types of waves. So V equals lambda nu. Lambda, we calculated before that, is 15 meters. And nu we calculated before that here is 0.1 hertz. So 15 times 0.1 equals 1.5 meter per second. That's for this example. Another example, we have here a vibrating string takes a time of 0.001 second to move from its rest position to maximum displacement position. Find its frequency. First of all, you have to concentrate well. If we have a pendulum, this pendulum, for example, we have here, if we have this, we move it in this way, so it takes a time 0.001 second. It takes time 0.001 second. But this is the time for one amplitude. Is it the time for one amplitude? But I want the time for the complete wave, for the complete oscillation. So it makes one amplitude, another amplitude, the third amplitude, the fourth amplitude. So we have 4 times for the amplitudes to calculate the periodic time. So we have first to calculate the periodic time times 4. So to calculate the periodic time here, yes, the periodic time equals 4 times 0.001 second equals 0.004 second. That's for the periodic time. And to calculate the frequency, frequency equals the reciprocal of the periodic time. So frequency or nu equals 1 over T capital equals 1 divided 0.0004 equals 250 hertz. That's for example. Another example, and this example is very important. As you see here from this graph, we have here the relation between the displacement in centimeter and the time in seconds. I want to calculate the wavelength and the velocity of this wave. First of all, here, if you look very well to this graph, here from this point to this point, to this crest, the distance is 30 centimeters, okay? And we start here from the original position. This is the original point here. This is the zero origin point. Okay, so first of all, I want to calculate the wavelength. Wavelength can be calculated from the relation, yes, distance divided number of waves. And here we have just this distance, 30 centimeters. We have to calculate it from 30 centimeters to meter. So 30 centimeter to meter it times, yes, 10 power negative 2. Okay, but what's about number of waves? What's about number of waves? Here from this point to this point, from this crest to this crest is one wave. But from this crest to the other side here, to this point, it is a quarter. This amplitude is a quarter of wavelength. Quarter equals 0.25, and we have one wavelength. One wavelength plus quarter, 1 plus 0.25, so it will be 1.25. So from this point, from the origin point, until it reaches to this crest, so the distance is 30 centimeters, and the number of waves is 1.25. So wavelength equals distance divided number of waves. Distance is 30 centimeter, calculated to meter, times 10 power negative 2, divided 1.25, so the wavelength is 0.24 meter. That's for the wavelength. What's about the velocity? To calculate the velocity is very easy. Distance divided, yes, distance divided the time. So distance here is 30 centimeter. To calculate it also, yes, times 10 power negative 2. Divided time, here's the time from this point to this point is 0.2 seconds. But to calculate this time at this point between 0.2 and between 0.3, the midpoint of them, between them, so it will be 0.25 seconds. So the velocity equals distance over time equals 30 times 10 power negative 2 divided 0.25 equals 1.2 meter per second. Another way, another solution for the wave velocity equals lambda times nu. We have here lambda 0.24 meter times nu. How can I get nu? Nu frequency. Frequency equals, yes, equals 1 over periodic time. Here the periodic time is 0.2 second. So 1 over 0.2, yes, 1 over 0.2 is the frequency. 1 over 0.2 is the frequency, means 5 hertz. So 5 hertz times 0.24, it will be 1.2 meter per second. Another example for these graphs are examples for the relation between the wave velocity, the frequency, and the wave velocity, wavelength, and wave frequency. Here in the first graph, we have here on the y-axis velocity in meter per second. On the x-axis we have the frequency nu in hertz. So the slope in this case, we make a division between the velocity divided the frequency. Of course, velocity divided frequency equals wavelength. So the slope in this case is wavelength or lambda. But here, velocity divided lambda. Velocity divided lambda, here the frequency is, yes, the slope is frequency or nu, because v over lambda equals nu. Finally, lambda and 1 over nu. Lambda divided 1 over nu means lambda times nu. Lambda times nu equals, yes, velocity. So lambda divided 1 over nu equals lambda times nu equals v, which is the wave velocity. That's for the graphs. Another question, which is what's meant by each of the following. Amplitude of transverse wave is 15 centimeter. Transverse wave, so yes, amplitude, so it is the maximum displacement of the vibrating body is 15 centimeters. That's for example. Okay, or the distance between 2 points, one of them the velocity is maximum and the velocity of the other is 0. This distance equals 15 centimeters. Okay, another question. The distance between two successive crests or two successive troughs equals 0.25 meter. It means the wavelength of the transverse wave equals 0.25 meter. Okay, another question. Distance between successive crests and the trough in a transverse wave is 0.4 meter. Distance between successive crests and the trough means, yes, half wavelength. So half wavelength equals, yes, 0.45 meter. So wavelength lambda equals 0.45 times 2 equals 0.9 meter. So the wavelength here in this case equals 0.9 meter. Here, distance between the first and 10th crest is 0.9 meter, means that the wavelength of the transverse wave equals 0.1. How? Here, in number 4, I repeat it again, if the distance between the first and 10th crest is 0.9 meter, it means what? What does it mean? Here, the first and 10th crest. First and 10th crest means, yes, from first one to 10th, so we have 9 wavelengths, 9 lambda. 9 lambda equals 0.9 meter. 9 lambda equals 0.9 meter. So lambda equals, yes, 9. Here, 9 lambda equals 0.9, so 0.9 divided 9 equals, yes, 0.1 meter. That's for the wavelength for this wave. Finally, here, the periodic time of a vibrating body is 0.02 seconds. It means that the time taken by the vibrating body to make one complete oscillation is 0.02 seconds. The frequency of a vibrating body is 200 Hertz. 200 Hertz means the number of complete oscillations made the vibrating body in 1 second is 200 Hertz. Wavelength of a wave is 1.2 meter. So it is the distance between any two successive points having the same phase equals 1.2 meter, as I don't determine the type of wave. Wavelength of a transverse wave equals 90 centimeter. It means the distance between any two successive crests or two successive troughs equals 90 centimeters. And the end. I hope to understood the relation